Okay, so we'll start off with converting a rectangular coordinate to polar. Okay, just to make sure we remember the letters they give you when you have a certain form. What are the two letters that they give you in rectangular? Do you know? You're going to start with an X and a Y. And in polar, what are the two letters you need to find? R and theta. Yep. Okay, so that's what we're doing right now. We're going to convert X and Y into R and theta. All right, so if I have an XY coordinate, just to make it simple, I'll put it in quadrant 1, but it can be in any quadrant. Okay. Y would be the vertical distance, okay, that I go down. Okay, so that's Y. Okay, X would be the horizontal distance from the origin over to that point. That's X. Okay, when we do an actual problem, you will know both of those numbers. Okay, they'll give you the X and the Y. So the goal is to convert them into an R, which is a radius, and a theta. So in terms of this picture, if you put the radius in, what shape would that kind of create here? Yep. It would create a triangle. And the radius would be what side of the triangle? It would be the hypotenuse. Okay, so here's your radius, which is the hypotenuse. And if you know the X and the Y, how can you find the hypotenuse if you know 2 out of 3 sides in a right triangle? Yeah, you can use the Pythagorean theorem. So I'm going to write this down on the next page a little nicer, but that's basically the formula that you use to find R. But I'll spell it out in steps on the next page. Okay, so there's your first formula. Now, what about theta? Where would theta be in this picture? Like, between what 2 sides here make up theta? Okay?
X and R.
X and R. It's right here. So our goal is to find this using the 2 sides that we know. Okay, so anytime we're going to do something with a right triangle, we've got to figure out the names of those 2 sides. Okay, what's the name of the side that's farthest away from theta? Is it opposite, adjacent, or hypotenuse? The side that's farthest away from theta. It's opposite. And what about the side that's right next to theta that we're calling X? That's adjacent. So out of the 3 trig functions, sine, cosine, and tangent, which trig function uses those 2? Tangent. So we can write down tangent of theta, and I'm going to write this again nicely on the next page. I'm just kind of writing it quick to show you. The tangent of your angle equals opposite over adjacent. Opposite is Y. Adjacent is X. Now, the only problem with that is we don't want the tangent of theta. We want theta. So what would you have to do to each side to get rid of tangent and get theta by itself? Yeah, we'd use the inverse tangent. Take the inverse tangent of what's on the left. It's going to cancel out. And do it on the right. And that's basically the formula for our angle. Okay, so now I'm going to write that out nice and neat on the next page. So to convert from rectangular to polar, the first thing you have to do is determine the quadrant. If you can do that without graphing, unless the problem says to graph it, you really don't have to graph it. But you have to figure out the quadrant. Because when you're finding theta, the formula that I just showed you guys, this inverse tangent y over x, that formula works fine as long as you're in quadrant 1 or 4. If you're not in quadrant 1 or 4, we got to make an adjustment to it. Just a small change. Okay, so that's why step 1, figure out your quadrant, and then once you know that, you can find your angle. If you're in quadrants 1 or 4, use this formula. Okay, if you're in quadrants 2 or 3, almost the same formula, except you have to add 180 to the front if you're doing degrees, or pi if you're going to do radians. Okay, so if you're in quadrants 2 or 3, in the front of the inverse tangent, put a plus 180. Or plus pi if you want to use radians. So with these two formulas, we've got it covered if we're in quadrants 1, 2, 3, or 4. Where else could we be? Being in quadrants 1, 2, 3, and 4, that doesn't cover everything. What do you mean in the middle? Should I?
0, 0.
Okay, if you're on 0, 0, that's kind of a special case of what I'm thinking of. Where is 0, 0? It's the origin, but where is that?
Straight line.
Well, what do you call that line? The axis. Okay, you could be on the axis. So if you're on the x or the y-axis, these formulas won't work. These only work if you're in the quadrants. Because, say we had that point. Okay, and I wanted to know the coordinates of it. What's the x-coordinate of that point? We know it's 0. We don't know the y-coordinate. It's up. Maybe it's up 1, maybe it's up 5. But it's 0 comma something. But if the x value is 0, what would happen if you plug a value of 0 in for x in that fraction? You can't divide by 0. Okay, so if you ever had an x-coordinate that was 0 and you try to plug it into this fraction, you're going to try to divide by 0. You can't do that. So that's why you can only use those formulas in quadrants, not on an axis. If you're on an axis, you have to memorize these 4 numbers. 0, 90, 180, or 270. It's one of those answers. If you're up, it's 90. Left is 180. If your coordinate is down, it's 270. And if it's right, it's at 0. How can you tell if a coordinate is on an axis? Well, how about what if you didn't have a sketch? That would be like a sketch, though. What if you don't? What if I just said the point 37? You should be able to tell quickly if that's on an axis or not, versus the point 07. Yeah, Kevin?
Either the x or the y is 0.
Right. If your x or your y is 0, then you're on an axis. Yep. Those are the easiest problems to do. If your x or y coordinate is 0, it makes the problem very, very easy. So now we've got all the quadrants covered. We've got the axes covered. That takes care of finding your angle. Okay. Then the last step we already mentioned is to find your radius. That formula does not depend on the quadrant. You use that formula all the time, no matter what. And it's really just the Pythagorean theorem to find the hypotenuse. Okay, so we'll try maybe an example or two of converting a point from rectangular to polar, and then that'll finish section 5.3. Any questions on the steps? Yeah.
What would you do for 0, 0?
Well, yeah, I'm not going to give you the coordinate 0, 0, because you really can't do that one. You got to have you can have one number be 0, but if both numbers are 0, that's like it's right at the origin. So technically, 0 comma any angle would be a point at the origin. Remember, we do that yesterday where you just spin in place. I think we did one like that. So there'd be an infinite number of answers to your question. So I won't give you that. All right. So first one they give us is 2, -2. And we know that it's rectangular because they're saying convert to polar. right, so Michael, if that's in rectangular, what letter is the first number?
X.
That's my x, and the second one?
Y.
Y. So when I'm done, I want r and theta. Okay, so first step, figure out the quadrant. Okay, so what I did is I numbered them here just in case you forget which ones are which. So Kristen, what quadrant is 2, -2 in? 4. It's right 2 down 2, somewhere right around there. Right, so Marcos, if we're in quadrant 4, what's the formula to find theta?
Theta equals tangent, or inverse of tangent, y over x.
Yep. Do you add 180 to it?
No.
No, not here. Okay, quadrant 4, it's just inverse tangent y over x. Okay, so fill in exactly what he just said. Y is -2, x is 2. So if I want, when I type that in on my calculator, I could just type in the inverse tangent of, what's -2 divided by 2? -1. All right, so on my calculator, you type it in exactly the way you see it, okay, in that order. A couple people brought me up a calculator yesterday. You have to type it in backwards. So if you have to type it in backwards and you'd rather use one of mine on the test, you can do that. All right, this problem didn't say if I should use degrees or radians, but I'm going to, I'll stick with degrees. And I'll do second inverse tangent of well, I could type -2 over 2, or I could have just typed in -1. Okay, so I get -45 degrees. Okay, that's my angle. And now my radius. Okay, so Kelsey, can you set up the formula that or the equation I'm going to use to find my radius? Yeah, just say it, what I would write down. Okay. Sure, you can fill in the numbers.
So 2 squared plus -2.
Yep, 2 squared plus -2 squared. And James, what's 2 squared?
4.
And how about -2 squared?
4.
4 again, so 4 plus 4
8.
gives me 8. And lastly, I want to get rid of the exponent. So Ariel, how do I get rid of the exponent of 2? Take the square root. And the square root of 8, that's a number that you can simplify. What does the square root of 8 simplify to? Miles? 2 square roots of 2. All right, yeah, I think, yeah, because you can break up 8 as 4 times 2. And then the square root of 4 is 2. Okay? There's a lot of different ways you can simplify it. As long as you simplify it however you want, that's fine. Okay, so there's my radius. Okay, so the last step is just to write the final answer. R, comma, theta. That's one answer you could put. How many different answers are there when you write a coordinate in polar? Yeah. 4. So if you get this and you're trying to match it up with a multiple choice question and you don't see that, it might be that you did everything right, but I just wrote a different version of that answer. Let's just write one other version. Let's keep the radius positive. And what can you add to -45 to make it a positive angle? So basically, instead of going this way, you're going to go the other way. 360. So going -45 is the short way. How much would it be to go the long way? Yep. 315. That's the same answer. Okay, and there's two other ways you could write it besides those. The other 2 ways would both have negative for the radius. Yeah. And the easiest way to do it would be to just draw it, go left, and then that way, left, and then that way. And you could figure out what the what the angle would be. All right, let's see. All right, so let's finish up. Try one more of those. Okay, take a second, try that one on your own. Okay, see if you can convert -4, -5 to polar. All right, so I just mentioned about that idea. It doesn't say whether you should use degrees or radians. So any problem that you write an answer to, there's 4 ways to write it. There's 8 ways if you include changing degrees to radians. But that's just a change in your units. Is there any question on how to change degrees to radians, in case that comes up on the test? Everyone's okay with that? So like, if you had 45 degrees, what's that in radians? Pi over 3 would be 60. But that is a common one that comes up a lot. This is pi over 4. So you could see this as 2√2, comma, negative pi over 4, if they wrote 45 degrees in radians. Okay. If you don't remember how to change it, 45 degrees, you multiply by pi, and you divide by 180. That's how you change degrees to radians. And then 45 goes into itself once, goes into 180 4 times. There's your pi over 4. And this one is negative. Okay, if, as we go through it, anybody has a question on degrees to radians, just let me know. But I don't plan on doing each problem twice like that. So, all right, so let's look at this one. Okay, convert to polar. Mercedes, what's the first thing you got to do?
Find what quadrant it's in.
Yeah, find the quadrant. What quadrant is this?
3.
Yep. It's left 4, down 5. So somewhere in quadrant 3. Unless they're asking you to sketch it exact, you don't really need to. Just figure out the quadrant. Okay, so we're in quadrant 3. Gabe, what's the formula to find theta in quadrant 3?
Equals pi plus inverse tangent y over x.
All right, so since you said pi, what units am I using? All right, so we're going to, because of what he just said, we're going to do that in radians. So pi plus inverse tangent, y over x. So what did you have for your fraction, Gabe?
Oh, just -5 over -4.
Yeah, -5 over -4. And when you type that in on the calculator, if you want to cancel the negatives, you can do that. All right, if he had said 180, I could keep my calculator exactly in the mode it is now. But since he said pi, it's good to practice doing it in radians. Make sure we know what we're doing. So pi plus inverse tangent of 5 over 4. Okay, so if you did it in radians, you should get about 4.04. Did anybody do it in radians? No. Okay, so if you did it in degrees, I'll tell you what you get in a second. So in degrees, let's see, we would multiply by pi and divide by 180. Whoops. Other way around, so 4.04 times 180 and divide by pi. So you should have gotten about 231 degrees. Anybody get that? Yeah? Okay. So if you did it in degrees and you got that, you're good.
218.
You get 218? That's a little bit off.
Yeah, no.
Yeah.
A little bit.
It should be about 231. So if we can double check after.
Sure.
See what went wrong. Now, when you find the radius, it doesn't matter degrees or radians. You're just going to square 2 numbers, add them up, and take a square root. The mode won't make a difference. All right. So we got r squared equals Emma. What's x squared in this case?
16.
16, and y squared?
25.
25. So we add them up, you get 41, and then take the square root. Usually, if you're going to round something off to a decimal, you might as well round everything off. So if you wanted to round off the square root of 41, you could just type it in. Yeah, it's about 6 point something. If you don't want to round it off, you can leave it. That's fine too. Okay, so your final answer would be r comma theta. And that would be 231 if you did it in degrees. Okay, that's one of the 4 answers you could put. Okay, if you had to figure out the other answers, I think it's easier to work in degrees rather than radians. But it's up to you.
How would you find the other answers if it's
To do it in radians?
in radians?
Um, Well, I'll show you one of them. So let's do the one where the angle is negative, okay, where we go the other way. So instead of labeling this using 0, 90, 180, and 270, I'm going to label it in radians. These are just ones I have memorized. So 1.57 is 90. 3.14 is 90. 4.71 is 270. And this is 6.28, 360. That's all the way around. Same as 0. So now we're at 4.04. Okay, that's about, say about like that. Okay, somewhere between 3 and 4. So if this part in red is 4.04 and it's 6.28 to go all the way around, how would you find that part right there?
6.28
Yeah, you just subtract it. 6.28 minus 4 point, what was it? 04? 4.04. So this part right here is 2.24, and it's negative. That's how you figure out the other angle.
Are we going to have to do that?
You might have to convert, because if you get a certain answer, I might write it, like if you got a negative, I might write it as a positive.
In radians?
Oh, you mean, would you have to do it specifically in radians?
Yeah, like you might have to memorize those numbers or whatever.
No, you could always figure them out if you had to. You just have to take 90, convert it to radians by hand. Take 180, convert it to radians by hand. It would take a while. Or the other way you could do it is if you didn't want to work with 4.04, change it to 231 degrees. Do the problem in degrees and then change it back to radians. That's kind of a lot of extra converting, but you could do it that way. Okay. So, any questions on how we got that other answer? I think it's easier to just do it in radians, but if you want to change to degrees and then back to radians, you could have done it that way. Yeah. Okay, so that finishes up, what was that, 5.1. All right, so the next thing we're going to look at is A.4. Okay, and for now it's going to seem totally separate from what we just did. I'm not going to make the connection between what we just did and what we're learning right now until Thursday. Okay, but I am going to connect the two in a minute, or a couple days. All right, so we're going to look at complex numbers. So the very first thing I just want to mention about complex numbers is they are not numbers that you use really in everyday life. Okay? They're numbers if you were in a very specialized field, maybe some applications of engineering, things like that. So if you're asking where would like somebody who repairs cars or a hairstylist or a chef, where would they use complex numbers? They don't. Okay, so complex numbers are really, they're used in certain fields, but they're really like engineering kind of stuff. So first thing I'm going to do is just kind of look at where complex numbers fit into the big picture of all the kinds of numbers we know. So I want to start with the simplest kind of numbers there are. Okay? Numbers that don't include fractions, no decimals, they don't even have negatives, they don't even have 0. Okay? They start at 1 and they go up. Does anybody know what those kind of numbers are? Start at 1 and they only go up. No fractions, decimals, no negatives. Yep. What kind? So whole numbers, yeah, technically you are right. Positive whole numbers or counting numbers would be the same thing. So counting numbers are the simplest numbers you can have. They start at 1 and they go up. But the problem if pretend that nothing else exists except counting numbers. Somebody give me a counting number, any counting number. 13. And I'm going to do some subtraction. I'm going to subtract 13. So if counting numbers are all that exist, you wouldn't be able to solve this problem because the number 0 does not exist with counting numbers. Even though we know that's the answer, counting 0 doesn't exist with counting numbers. It starts at 1. So basically they invented a new number. They invented a number 0. Okay? And 0 represents having nothing. Okay. So Jamel already said the name of that next set. The next set of numbers is called whole numbers. And the only difference between whole numbers and counting numbers is whole numbers have 0, counting numbers don't. So now we could answer that question. We could do 13 minus 13, and we know what to call it, because we have a name. We call it 0. But we could still run into some problems here. Not with addition. Okay, if you were to take a whole number plus a whole number, I think you'd be okay. But can anybody think of another subtraction problem that we wouldn't be able to solve if all you understand is whole numbers? I want to think of a subtraction problem, subtract 2 whole numbers, but the answer would not be a whole number. Okay?
Oh, 4 minus 6.
4 minus 6. All right, that's a big problem. So he's trying to take away more than you have. In terms of like everyday things, like if you had objects in front of you, that's impossible. If I have 4 objects and you want to take 6, well, good luck. I only have 4. You can't take more than I have. So they had to invent a new kind of number to represent even less than 0. Okay, it's like, negatives. So does anybody know the name of those numbers? We still don't have fractions, but now we can have negatives. Begins with an I. Integers. Yep. And if you think about like really simple things you can do with numbers, like think like old-fashioned stuff. Like if you're trading things with people, you would never trade negative numbers of stuff. Okay, the idea of owing something to someone, really that idea didn't always make sense. Okay? But now we have a way to represent it, okay, with negative numbers. That means you would owe something, whether it's debt, on a loan or something like that. You can think of that as negative money. But even with integers, there's another arithmetic problem that could happen. Can somebody think of something you can do with integers, some arithmetic, and the answer would not be an integer? Jamel? 7 divided by 3. Now we have another problem. So no matter how many positive or negative integers you try to use to represent this, you can never figure this problem out. Because now you're trying to take 7 objects and divide them between 3 people. But you can't do that. You can't divide that evenly. If you had 6 objects, you could divide that to 3 people, but not 7. So now they have to get into the idea of using parts of numbers. So again, they invent something called a fraction. Okay? And those are your rational numbers. And for everyday purposes, like kind of stuff you do in everyday life, I'd say rational numbers are probably as much complexity as you really need. Rational numbers are used all the time. Think of like when you're cooking. You might use 2/3 of a cup. You don't need 1 cup. You don't need 0. You don't need 1. You need something in the middle. If you buy something at a store, a lot of times things don't cost exactly $5 or $6. It might be like $5.72 or somewhere in the middle. Okay, so we have parts and decimals, fractions. So all the numbers that we look at beyond rational numbers, it's getting more theoretical now. Okay, not as much of an everyday kind of use. reduce. So we've got rationals, and there's a type of numbers that are the opposite of that. Okay, rational is basically anything you can write as a fraction. Does anybody know the name for the numbers that are opposite of rational? Irrational. Okay, so irrational are numbers that it's impossible to write them as a fraction. Does anybody know a number that you can't write as a fraction? Yep. As far as we know, they haven't actually proved it, but they've listed a bunch of digits of pi, and they've never found a pattern that it repeats and does the same thing. If a number goes on forever, like 1/3, you can write, even though it's 0.3, it's the same number that goes on forever. So you can write that as a fraction. But if the numbers are just kind of random and there's no pattern to it, you can't write it as a fraction. So pi is an example of irrational. Anybody think of another number? No, actually, numbers we've used today that are irrational. So if you had 0 over something, that would always come out to 0. So that would be undefined. So that wouldn't even fit on our chart. We would just say it's just not even a number. It's undefined. But good guesses. Think about when we were finding the radius. What happens a lot of times when you find the radius in a triangle? You have to take a square root. So any number that doesn't come out nice, like square root of 5, square root of 6, square root of 7, square root of 8, those are all irrational. Numbers like square root of 9, square root of 16, that's fine. Okay, so all the numbers that you can write as fractions and the ones you can't write as fractions, those are your reals. Okay, that's the real number system. And when you take Algebra 1, those are the numbers you study. That's everything. But just like all these problems, okay, each time we looked at a new problem, we had some difficulty. We couldn't do it because we didn't have the concept of 0, or we didn't have negatives, or we didn't have fractions. Well, here's another one. If I wanted to solve that, what would I have to do to both sides? I'd have to take the square root. And that's the answer. Now, if all you understand is real numbers, or you were doing this problem in Algebra 1, on the test or something, I would accept the answer undefined. I'd say you can't do that. But saying that you can't do this is the same as saying you can't do this. Well, yes, you can. If you invent something that would give you an answer for it. So like we invented negatives, or we invented fractions. Well, does anybody know what kind of numbers you have to use here? Imaginary. So if you have a problem like that and you can't solve it, they invented a type of number system that would solve it, just like all of these. So those are your imaginaries. Okay. And together, if you look at all the real numbers and imaginary numbers, that makes up the complex number system. Okay. And complex numbers are always made up of two parts. Okay, a real part and an imaginary part. And that's where we'll start out. So in Algebra 1, technically everything you study is a complex number. It's just the imaginary part was always a 0. So if the imaginary part is a 0, we don't write it. You don't need to. But if the imaginary part is something that's not a 0, then you need to write it down.
Is it an A?
Yeah, that's an A. So here I wrote an example of a complex number, 2 plus 3i. 2 is the real part. 3 is the imaginary part. Okay, not 3i. The I is just there to tell you what's in front of it, is the imaginary. And that's usually how you write it. Real part first, and then imaginary part. Okay, that's called standard form. Okay, that's just always the way you write a complex number. Real part, imaginary part. Okay, that's what I just said to you. 2 is the real part, 3 is the imaginary part. Is anyone in engineering? Shop? No. If you know anyone in engineering, I know they do use complex numbers in that shop. I've never asked the teacher exactly how they do it, but they are used in that shop. But they're not used in many other areas. Okay. If a number doesn't have a real part, okay, pretend like the 2 wasn't there and you just wrote 3i. Okay? That's called a pure imaginary number. Okay, so these two numbers, 4i, negative 2i, they would fit in this box right here. They would just be a pure imaginary number. They would have no real part to them. Okay, we haven't really talked a lot about what that I means. I'll talk more about what that I means, but for now you can just think of it as meaning it's imaginary. That's what the I means. But even though that I, it's a letter, right, in the English alphabet, I is a letter. I is going to stand for something. Okay, I'm not going to answer that question right now, but I will in a little bit. Okay, I stands for something, just like this. You might say, oh, well, that's a letter. Yeah, in Greek, pi is a letter, but in math, that stands for something. Specifically, it stands for 3.14. So in a second, or in a couple minutes, we'll answer what does I stand for. It is a letter, but it stands for a number. Okay. Just like pi. All right, so what does it mean for two complex numbers to be equal? Well, when you have a complex number, what's always the first part in a complex number? The real. And what's the second part? Imaginary. So if you have two complex numbers and somebody asks you, are they equal? You have to check two things. You have to check that the real part in the first one matches the real part in the second one. And the imaginary part in the first one matches the imaginary part in the second one. Okay, with regular numbers, or just real numbers, you don't have to check two things. You just have to check one thing. But complex numbers have two parts, so you need to check two things to see if they're equal. So there's an example of two complex numbers that are equal. The real parts match, and the imaginary parts match. Okay, it's pretty straightforward. I just want you to remember that complex numbers have two parts. Okay, if I did something like that, now the imaginary parts match, but one of them has a real part of 3, one of them has an 8. Those don't match. So these are not equal. Now they are. Okay, so any question on what it means for complex numbers to be equal? All right, so starting today and finishing tomorrow, we're going to look at all 4 basic things you can do with complex numbers, arithmetic-wise. You can add, subtract, multiply, and divide. Okay, adding and subtracting are the easiest two to do. And when we add and subtract, we're not going to really do it with word problems. Okay, I'm just going to give you a calculation like something like that, and I'll just say to add them. Okay, word problems with complex numbers are really, really challenging, and oftentimes they involve math that we don't even know, like calculus stuff. So we're not doing word problems with complex numbers. All right, so when you add complex numbers, all you have to do is think of it as like combining like terms. You're allowed to combine real parts with real parts, imaginary parts with imaginary parts. So if I was going to add these two complex numbers up, A, B, C, and D would all be numbers, just like in this problem. All numbers. I would take the two real parts, add those together, and then take the two imaginary parts and add those together. And don't forget to put an I next to the imaginary part. That's important. Okay, so let's add these up. So we've got 3 plus 8i, that's my first complex number. 8 plus 2i, that's my second one. And I'm going to add them. So Becky, what's the real part in the first set of parentheses? 3. And Jamel, what's the real part in the second set? 8. So we just add 3 and 8. The real part in the final answer is 11. Any questions on that? Devin, what's the imaginary part in the first parenthesis?
8i.
Yep, we get the 8. Yeah, that's fine. So we got 8. And Jacqueline, what about the real imaginary part in the second one? 2. So we're going to add 8 and 2. We get 10i. And that's it. That's the final answer. That's how you add two complex numbers. Not today, but tomorrow we're going to learn multiplication. And I think once I show people that, they mix this up with multiplication. There's a time where you have to do the distributive property in FOIL. It's not when you're adding. Okay? To add, you do it just like we did. All right, so try 1B and 1C. Just take a minute, see if you can add those up, and then we'll finish up with subtraction. So Riley, what did you get for the real part in example 1D? All right, how'd you get that? What'd you do? 8. So when you add the real parts, you got to grab the real part from here and that one. So if you add the two things I just circled, that would give you a real part of 7. Yep. Okay, and how about Miles? What'd you get for an imaginary part? Yeah, -2 plus -8, -10i. Okay, and then example 1C. Graham, what do you get for a real part there? Yep, -3 plus -7. And the imaginary part, -4 plus +8. So it's +4. Yeah, +4. Okay, any questions on that? Okay, so if you can do adding, subtracting is pretty straightforward. The only difference is you have a subtraction sign, you need to distribute it out. Okay, so when you do subtraction, it's going to be A minus C and B minus D. Okay, so anytime I have subtraction, that's how I think of it. So A minus C and B minus D. The sign between them, that depends on if B minus D is a positive or negative number. If B was 2 and D was 5, 2 minus 5 would give me a -3. So we'll do a couple problems and you'll see. Okay, so the point is just don't forget. A lot of people will subtract the 3, but then they also forget to subtract the 4i. They add it instead of subtracting. So Trevor, if I do this one, what's 4 minus 3?
1.
1. So real part's 1. And Henley, the imaginary part, it's 12i minus 4i. Should be how much?
Just put 12 minus 4. Eight.
Yeah, you get 8i. Right? So 12 minus 4, 8i. Okay, any question on that?
Oh, plus 8?
Yep, that's a plus 8, because it's positive 12 minus 4. It's 12 minus 4.
Oh, the subtraction is from the 3 and the 4.
Yeah, you're subtracting the 3 and you're subtracting the 4. So think of it as like a distributive. If this was a plus, then it would be 7 and 16. They would both change. All right, let's put that back the way it was. Okay, let's try this one. So 3 minus 5i, that's your first number. And then you're going to subtract 8 minus 6i. Now, all the rules you know about subtracting with regular numbers, they still apply here. So keep that in mind. So, Brianna, what did you get for the real part?
Negative 5.
Yep. Yep, 3 minus 8. What I'll do is I'll write this in 2 separate parts just so we can see the calculation. So we got 3 minus 8. And then what about the imaginary part? What's going to happen there? Yeah. When you distribute this out, you're basically going to have negative 5i minus 6i. Any question on that? So your 3 minus 8 is negative 5. And then, Gladys, what's negative 5i plus 6i?
1.
Yep. And that's kind of a point that comes up sometime. You can put the 1 in front of the I, or you can write just I. Both ways would be correct. Okay. Any questions on that one? All right, so the last thing is I told you earlier that I stands for something. Okay, it's a letter, but that letter is used to represent a certain number, just like the letter pi is used to represent 3.14. So the letter I is the square root of negative 1. Okay, and notice how I wrote that. I said define. Define means I can't explain why. It just is. Okay? If you ask me to explain why, that's like asking me why parallel lines don't cross. They just don't.
Why?
Because they don't. Parallel, it's a definition. So in math, sometimes you got to start with some fact that you can't always explain. And from that, you can build other facts. Okay? So why don't parallel lines cross? That's the definition. They just don't cross. Why is I the square root of negative 1? That's just the definition. So if I is the square root of negative 1, then we can figure out what I squared would be. What does I squared mean to do? Like if you had to write that out so somebody doesn't understand what exponents mean, how would you explain that?
Square root of negative 1 times the square root of negative 1.
Yeah. I squared means to write I times I, which is the square root of negative 1 times the square root of negative 1. Okay. What do you get when you multiply those together? The square root of negative 1 times the square root of negative 1. You get negative 1. It's just like if I said, what's the square root of 3 times the square root of 3? It's 3. The square roots cancel out and you're left with the number underneath. So we get negative 1. Okay, and that's going to come up a lot tomorrow when we multiply. Okay? And you could figure out what I cubed is, I to the fourth, and there's a pattern after you do the first four. But these are the only two that you need to know. I is the square root of negative 1. I squared is negative 1. So if you had something like this, 4i squared, what would that simplify to? That's negative 4. Okay, so anytime you have an I squared, don't ever leave I squared in the final answer. Always change it to a negative 1. And then do out the arithmetic. That's how we got negative 4. Okay, so any questions on that? Yeah.
If we had a negative 4i, would it be a positive 4?
So if you had, yep. So negative 4i squared means negative 4 times negative 1, because I squared is negative 1. It's a positive 4. Yep. Okay, so we'll see a lot more with I squared when we multiply tomorrow. All right, so the homework. Okay, tonight the first part is on converting between polar and rectangular, what we finished up. The second part is on adding, subtracting, adding and subtracting complex numbers. Okay, so the goal tomorrow is we'll finish multiplying and dividing with complex numbers. And then we'll start section 5.3 and finish it on Thursday. Is anybody going to skills, the states? Okay, so I mentioned, yeah.